Welcome, everybody. I'm very happy today to have Professor Krintz from UCSB, who is the vice chair of the computer science department there. And her focus is on AI in smart farming and ecology. So these are two of our favorite topics here at the AI Guide. And we're very happy to have you today. Thank you so much for joining us.
Well, thank you very much for having me. I'm very excited to be here.
Thank you. So would you please tell us how you got interested in computer science generally and AI specifically?
Sure. So it started when I was very young. I was 8 years old. I lived in the Midwest in Indiana, and my dad was a principal at a middle school. And there was a computer at that middle school, and he wanted to keep it safe. So he brought it home for the summer. And he allowed me to play with it for the summer. I'd never seen it. I'd never taken a class. I didn't know, there was really no programming back then. And it just opened my eyes to what was possible with computer science. Learned how to program it from magazines in the grocery store that my mom would buy me once in a while. And I wrote my first program when I was 8, and it would display colors on the screen according to the music I was listening to.
Oh, that's really neat. Wow, it's so great to have found something you were so excited and passionate about so early. That's great.
Absolutely. And then AI, that's been much more recent. I'm a computer systems person, so I design the software that makes computers run and makes apps easier to write for those computers. And I had done co-founded a startup company in cloud computing, where we used lots and lots of huge computers in order to solve problems and to help businesses solve problems using the internet. And when I was coming back from that stint at starting that company to UCSB, where I'm a professor in computer science, and I was teaching a class, a student senior projects class called the CS Capstone, where we put teams of students and we pair them up with industry mentors. And the industry mentors have to come and pitch their ideas, and the students pick and choose, and not everybody gets chosen. So it's really competitive and it's very exciting. And one of the companies was Powwow Energy, and that today they're called Ag Monitor. And they had this wonderful pitch. They were on the forefront of AI for agriculture. I had never seen it. I had never thought about it. I had a farm when I was growing up, but I was never involved in it from a computer systems perspective. And they presented this project, and the students picked it, and we all worked together, and that started a collaboration. And that was in 2014 that we're still working on today. I still work closely with them. They are a tremendous company, really cool stuff, still doing AI for ag, solving all kinds of cool problems. And that's how it was started. That collaboration allowed me to think about the problems in bringing technology like artificial intelligence to agriculture and what the challenges were in collaboration with Powwow Energy. And that allowed me to go to the government to raise funds. And because that's how computer science works. We have to raise funds in order to get students. We pay our own students to work on our projects. And so that allowed us to build a team of students at all levels, and to pay them as they were going to school as part of their education, and then to work on Smart Farm. And that's when UCSB Smart Farm was born. And it's still going strong today. And there's all kinds of cool problems to work on.
Terrific. So one of the things I've mentioned to my viewers before is that cloud computing has really been a great enabler of AI. Do you agree with that?
Absolutely. It's where it was started. It is what rekindled AI. AI has been around, as you guys know, forever, since the early days of computing, because of its foundations in mathematics. And only recently has it really been brought to bear in a way that it's general, that's broad, that can impact lots and lots of parts of our society. And it was really driven by the big internet giants, Amazon and Google, and Microsoft, Microsoft and Facebook, who were really these web presence, these internet giants that had these web apps that we were all using, and they collected vast amounts of information about us, and were able for the first time to make significant breakthroughs and using that data to make recommendations for us, to get us to buy more, or to tell us what direction to go, or to start to automate a lot of our processes. So a lot of that work for really focused on social networking and internet e-commerce was then turned into a movement to really develop artificial intelligence. And that was for not just to make predictions about society or groups and trends of what was happening. It was so powerful, and the algorithms that came out of that were so powerful that these companies were able not only to make predictions about groups, but about individuals. They could tell what I wanted to buy, when I wanted to buy it, and how much I would pay for it, by looking at what other people were doing. And that was a huge breakthrough. And so that started it all. And that was really the birth of cloud computing as well, because we needed lots and lots of computers to hold this data, to process this data, to chomp on this data, to make these predictions and inferences. And so that was where all of this was, the AI was rekindled and then made really publicly available. And we could see the value of it. And really, that is where, when I was coming back from cloud computing, that's where a lot of the ideas to move to agriculture were also reinforced, because there's lots of society and parts of our economy that are tremendously underserved by technology. And agriculture and ecology are two of the big ones. There's not a lot of them. There's not a lot of farmers. There's not a lot of people doing this, and they don't make a lot of money. They don't have high, big margins. So that AI and that recommendations and that e-commerce really didn't get pushed all the way through society to these underserved regions. And that's why my team and I at UCSB felt it was our obligation in academia to produce systems and push them out to these underserved areas of our economy, so that everyone could participate more broadly in this technology boom that was happening.
That's really terrific. Yeah, we talk a lot here about converging technologies, and certainly cloud computing and AI are two of them. But before we came on, you were also talking about sensors, IoT, and that's another aspect of these technologies that are all converging. Would you please give us a little insight into that?
Absolutely. It's also very exciting and a huge change. Our computers over the last decade or so we've been able to shrink them down to be really, really small and very energy efficient. And that change allows us to put tiny little computers really everywhere, on our tables, in our desk, in our coffee mugs, in our refrigerators, in our cars, in our backyards. Because the price was low and they're so small, they can really go anywhere. We still have to battery power them, which is a challenge. But a lot of them, but that technology is improving as well. And as soon as we're able to sense everything around us in our environment, in our everyday life, we're able to do, very basic sensing, just measurement of our environment, like what the temperature, what the humidity is, all the way up to, interesting cameras that are, really low cost now, and we can monitor gather lots of information from cameras. And by connecting them with networks so that we can get that data off of them, now we have, just boatloads of data all about everything in our environment and all the objects we interact with. And that's the third pillar. So you got the sort of the cloud computing, the artificial intelligent recommendation engine. You've got these, these sensors that are gathering information. And then you have the systems that are bringing it all together. And that's what I work on. I work on how do we bring these technologies together in a way that's robust and trustworthy and easy to use. All of those problems haven't really been solved well yet. We can monitor, we can run in the cloud, but bringing it all together and having it work in your house or on a farm or out in the wild at a research reserve or is really challenging still. And so that's where I think the forefront of AI systems is, and that's what my team works on.
Yeah, and you said trustworthy. Would you elaborate on that for a minute, please?
Yes, absolutely. So that's a loaded word for artificial intelligence. There's lots of ways these devices and systems can make mistakes. There's lots of ways that bad actors can manipulate these systems to make the world do things that it shouldn't or harm people. And so a lot of what is happening today and what will need to happen in the future is, how do we know, how do we know the data that this little tiny device in the soil in our garden is telling us the right answer? Devices fail, software fails, bad things happen, but also they could be manipulated to give us the wrong information. And then you're making bad decisions. So a lot of people are working, and not myself directly, on how to, one, look at how to make the gathering of information more trustworthy. How do we make that information trustworthy? How do we make the algorithms that operate on that data more trustworthy? And the one thing that I am really interested in is kind of a third pillar of trustworthiness, and that is, how do we know that the recommendation we're getting, or the advice we're getting, or the decision support, or the algorithm that's driving my car, how do we know that it's making the right decision? How do we know if the recommendation we just got is something that is correct or, again, trustworthy? Artificial intelligence is a very large field, as you all know. There's a lot of statistical techniques that we can use to kind of reason about or diagnose when things are right or why things are right. Why did we get the answer that we got? But there's a lot of AI, in particular neural networks, that we don't understand well. And when we get an answer, we can't just say, how did you get that answer? Because it's really unclear and it's a black box. And so there's also a trustworthiness that comes into play when we get a recommendation. How is a farmer going to trust that my system's going to put on the exact amount of water or the exact amount of pesticides that he needs? He wants to know how I came up with that recommendation. If I used a neural network, I may not be able to explain that to him. And so trustworthiness also comes with the explainability of these AI systems that we're developing. And that still needs a lot of work. There's lots of amazing people working on that, and that will still need to be pushing forward on. And it's a great area, very hard and very interesting, but very, very important for AI to continue to take off as it has.
Yeah. Do you find the trustworthiness in terms of recommendations improves with more data?
Not necessarily, because if I just tell you, you will wear a red shirt tomorrow, and maybe you will, maybe that'll make you happier. But why? Why did I tell you that? And I'll say, I had tons of data, and it all says tomorrow's red shirt day. But if you don't really understand how we arrived at that answer, you're at a huge disadvantage. I could be manipulating you. I could, be making a fool of you. That's just it's a silly example, but that happens all the time. And more data, yes, is really important for AI to make just decent recommendations, but understanding how those recommendations were arrived to, or having some kind of reinforcement that allows us to trust. So like maybe two independent systems, right? What do? We get independent bodies to look at a problem when we're not sure of the trustworthiness of, one company. We'll get a second company. We'll get a second opinion from our doctors. We need second opinions. And if they're independent, that can also be a way of enhancing the trustworthiness of the recommendations we're getting.
Terrific. So I think my audience would love to know, since you're in academia and at one of the top computer science departments in the country, what is your perspective on the role of the academic community with regard to AI versus the commercial community, private businesses?
Yeah, I think it's really important. I think this is one of the areas that where academia has to play a role, because companies are necessarily driven by the bottom line, and their outlook is typically short term, so that they can, continue to please either their stockholders or the shareholders or their investors. And so they're restricted to solving problems in a way that enhance the commercial viability of their solutions. Academia is really important because it can look at sort of medium term and long term visions and options. In academia, we get what's called tenure, which is when you're a professor long enough, you get a job for life. And what that does, it gives us the ability to work on really hard problems that industry is scared to death to do, because they don't know if it's going to pay off. I can work on something that will fail. And if it fails, we learn and everyone benefits. And so academia plays a really good, unique role that way. And because these systems are so complex, all these tiny little sensors and that are everywhere in our environment, huge, large scale systems, number crunching and analyzing this data, and then recommendations engines that are trying to control and actuate our lives are so important. And therefore, and so challenging and so complex that we really need lots of people looking at this. The other thing that academia and computer science and UCSB in particular offer is a diverse set of students from lots of different walks of life, from lots of different backgrounds, that can think about the problem in different ways. And that also informs the future. What is the future of AI going to do? How is society going to benefit? How do we ensure it benefits and isn't hurt? All of that is more risky. And academia is really there, I believe, to take on some of that risk so that industry later can benefit from all of that.
Yeah, thank you. That's a great explanation, that academia can take risks that private companies can't, because they can't necessarily afford to lose time and money on a project that doesn't work out, that's very complex. So thank you.
Exactly.
I was very interested to see recently that the EU issued draft regulations surrounding artificial intelligence. I don't know if you had seen that draft or heard very much about it, but I just wondered, from an academic perspective, what's your thought about this effort that's just started in the EU?
Yeah, so I've seen a little. I haven't had a chance to read it myself all in detail. I would comment that it's early days, and a lot of times, sort of, there's a delay in terms of what the cutting edge technology is and the cutting edge understanding is, and then how it impacts society. And government and government regulators and people looking at these problems are trying to manage any type of disadvantage or lack of fairness. And so I think it's good to constantly have a conversation about this, but it's got to be a living document. We have to be constantly learning, because, even the experts aren't really expert. There's so much to know. Like I said, these systems are so complex, and how they impact society is really something that's hard to predict. Humans are not good at predicting. Machines are, but humans are not great. And so I want to be part of efforts like that. I think it's important for all of society to be engaged in the discussion about the future of AI and what it means and how we protect ourselves and keep out bad, harmful players. At the same time, it's got to be something that evolves. You can't put it in stone, because it's already past its prime by the time you get it out. So that's the challenge, and that's a challenge that's been with our technology. We've had these struggles before. We've seen how it works, but before, there's always this delay. We've got to keep an open mind and constantly be vigilant about when bad things happen, and then use that learning to then establish the right set of rules and regulations that we need to protect people. But it's going to be a give and take, I believe. It's not, it's just, if it's so complex, it's so hard that but that's another point I'd like to make actually, is that everyone needs to understand how computer systems work, how to innovate, how to use AI for good. And they can't all be computer scientists. We can't educate the world and make them computer scientists. It's got to be everyone just pursuing their own hopes and dreams, but being able to leverage computer science in their everyday life. And we're constantly working on that balance as well, because the politicians and the people who are establishing our policies need to be informed and able to understand how to make those decisions. And we need to help educate them. And that's why academia has to play a big role in this, in these early days, especially.
Great, thank you. That was a really helpful answer to help people understand the limits of regulation in terms of the speed at which government entities can work and how quickly they can adapt to a technology that itself is adapting very quickly. And that brings me to a thought I just had. You've been working in computer science for a while now, and what have you personally seen in terms of the rate of change in your field over time?
It's been incredible. It's insane. I don't know how we've even been able to keep up, but it's incredible. The biggest change is that it's much more broad. It has impact so widely across society. Whereas in the early days of computing, when I was starting out, your job prospects were to be, you'd work in some basement or in some cubicle all alone in a box, and you would be, this genius that was solving problems, and there'd be 17 of you. Today, everyone needs to have this, and all of the computer scientists that we're producing, they don't necessarily even work at high-tech companies. They work in healthcare, they work on agriculture, they work, in government, they work in manufacturing. The people that we're training today are going out into all kinds of different industries and impacting society that way. And so it's been both the technology that's changed a lot, but also the educational process and what a degree looks like in computing. And that's evolved as well. And so being in academia has been really exciting, I have to say, in the last 20 years because of all these changes. It's been exhausting, but also extremely exciting. And we've constantly kept on our toes. And I don't think it's going to stop. I think there's the next decade is going to involve lots of changes in both technology, how it impacts society, and how we educate the future technologists and innovators in our society.
Great. And going back to your focuses of smart farming and ecology, I've shared with my viewers how the first fully autonomous tractor rolled out in 2018, which is not that long ago, and how there are companies who are already commercializing some of the technologies that you've talked about today, specifically pesticide application, fertilizer application, overall crop management, including using satellite data and stuff like that. What is one of the opportunities that you see right now that my viewers wouldn't know about because it hasn't come out in a commercial way yet?
That's a really good question. I would just say that there's the commercial sort of impact has solved those problems, like precisely applying pesticides, trying to do more automation on farm. I would say that it's not anywhere near commercial yet, but the future of farming is really going to be making decisions, or what it's called farming by the inch. And that is, if you can make a decision about every plant, and you can't do it yourself, there's no human that's going to do it. And today it's just unreasonably costly. But if you can make a decision to dial in the environment for every plant and make every plant super productive, apply just the water, just what it needs, and not just, applying to a large area, some particular treatment, you're going to reduce costs down to the minimum, and you're going to enhance the productivity of that plant. And you can do this for animals as well. And so we can, I think the future of farming is going to be really automated, really precise, where we can understand, all of the different, parts of our soil and our individual plants and make decisions about them. And that's all going to happen with automatic systems. And then we'll have our farm workers will also be technologists. They will use technology to their advantage. They'll be able to do more. It'll be less manual. So the labor will be, more automated, more done by robotics and machines. And I think it'll be better for everyone. But that transition to get there will take a long time, and it'll be bumpy. It won't be perfect. I think that's also something to take away as thinkers about the future of AI. We think it's all, roses, but there's going to be bumps in the road, and there's going to be lots of challenges. And we need to make sure that we bring everybody in our society along with us as we're solving these problems, especially in ag and rural communities. I think there's a tremendous opportunity to solve some really interesting problems.
Yeah, what you just said is very interesting because it ties in to one of the major themes we focus on here is how do we prepare people like your typical farmer for this type of technology? How do they learn about it? How do they get comfortable with it? And these technologies are going to pervade all of society in every area of life. So what you'll say about the farmer will apply to everyone in everything going forward. So yeah. What do you think about that?
I think the transition to that is going to be rough. I think that we'll have to pay attention to who is at a disadvantage, and it's because it's really hard to learn if you've already, let's say you've become a specialist in agronomy and now you have to learn all these technologies. Sometimes that's really hard. But like I said before, we're kind of an impatient people, but technology is going to be around for a long time, and it's going to be going across multiple generations till we get to the point of something like I talked about, which is, farming at a very fine grain, very site specific way. So in that transition, there's going to be multiple generations of people coming through. And that's where I think academia plays a really important role. We have to adapt to introduce a much larger population to technology basics. But this can also start in the K through 12 level. We are involved. We also participate and try to help out our K through 12 comrades. And I think the education there is going to change. And so what I would do is I would encourage young people, because they're going to be the ones that are going to be, those smallholders, those farmers of tomorrow, those people in society that are, in manufacturing, and it's going to be a few generations. So as we educate those people, we can make sure that technology plays a huge role. But I'd also encourage young people, not to just be users of technology. Don't just sit around and look at your phone and play games on your app. Think about how to design that game. Make a game yourself. Dig in, open that phone. Don't tell your parents I told you, but break into it. Be curious. Figure out how it works. If you want to have these abilities and to have them before everyone else does, being curious and really pushing on how things work, not just being passive users of technology. That's great because you're comfortable with it. You still will have a huge opportunity, but get in there and see how these things work. And I think as we introduce young people across the United States, across the world, with the ability to be curious and to be comfortable with electronics and problem solving and writing software, programming, those are the building blocks that then they can use to innovate. And then if more and more people can innovate, we we're off to the races. We have really diverse views on how to innovate, how to affect society, and that's only going to make our society richer.
Great, great. And on the ecology side, we've seen Peter Diamandis and the X Prize Foundation launched two very interesting things in the last years, 2 years. One was the underwater mapping of the ocean floor initiative, and another is now the mapping of the rainforest initiative. So what are some of the opportunities and challenges you see with using AI in ecology, especially in light of the dynamics of how the environment is changing? In our pre-conversation, you mentioned the drought in California, which I think a lot of people are aware of after last fire season. So what are some of the opportunities and challenges you see in ecology, and how might some of these issues be addressed in your mind?
Yeah, so I think there's two big things that happen there. They play a role in ag, but not as much, because in ecology, these wild spaces, either underwater in the ocean or in the backcountry of the mountains or high plains, these are terrains that even humans don't venture into often, that we want to observe. So I think there's huge opportunities in observation systems, either ground robots or drones or satellite imagery, and then combining those things. Because until we can't solve problems like these prizes show, we can't solve problems until we understand what the situation is and how it's changing. And to do that, we must observe. So I think the early opportunities are in observation technologies. They have to be super cheap and at the same time super robust. They're out there in the wild, right? They have to operate on battery power, so therefore solar or some other form of energy to power them. Those are really hard problems, and we've been designing systems. This kind of gets back to my area. We've been designing systems that are in our pockets, that are on our desks, that are carried around in our headphones. That's where our computers have been. They've been indoors. They've been in nice environments. These environments are not nice. They are harsh. They are hot. I have computers on my farms that get into the 130-degree range, just in their little enclosures that they're sensing in. And in the winter, they're frozen. We have to design systems to deal with these extremes. I've had farm workers step on my equipment. There's animals out there, pooping on the equipment. There's the amount of things that happen in real life out in the wild are incredible. And we haven't thought of really hard, or a lot of people haven't thought about really hard, how to design systems to be robust to that. Because until we have that, we can't just, easily put these devices out. Some human has to go out there. And if a human has to go out there, we're done, because it's that we just have too much space, and it's too wild, and it's too expansive, and it's too varied to just use a general purpose tool to go and measure. So I think devices need to change. New systems need to be designed so that these devices are more robust and resilient to harsh conditions. And then the last thing I'd like to say is the data analysis piece. We're collecting lots and lots of data, but some people are developing really cool, amazing analytics and recommendations and artificial intelligence, but the data is increasing at a much larger rate than the advances in the software and the algorithms, and that's necessarily going to happen. So the opportunity, until those things get some more parity, is to learn. And I encourage you all to figure out what you're curious about. Go after those data sets that are being made available publicly. Even 5 years ago, there was not even 1/5, 1/100th of the data available to the public. You can go get those data sets. You can learn how to become a data scientist. You can learn how to find patterns. Try to understand what information that data holds. It's a huge opportunity, and you don't need to write code for that. You can actually just study the data and what's happening there, and be educated in terms of the tools that are out there to do data analysis, and that will inform how we automate things later. Because if you understand the data and you understand where the patterns are, or maybe where the opportunities are that the data is giving you, then we can later write code to do that automatically. But the human has to do it first, and we need lots of people involved in getting into this. So that's another opportunity of something. If you're curious and you're sitting around but you don't have someone to teach you how to write code yet, go and see what's out there. Go and see what these ocean monitoring systems are giving us. It's really amazing, and they don't have time to go through it all. So it's really important for society to get involved. You hear about it as kind of citizen science sometimes, but it's out there. There's tons of data sets. There's tons of images. There's tons of videos that people need help analyzing, for you to help us tell us what's going on in those, so that then we can get the computers to do it automatically and check that the computer is right automatically. But we need humans to do that initial work. And that's where I think this early day opportunities are.
Yeah. Is there something else that you're working on right now that we haven't talked about that my audience would find interesting? And tied to that, do you have, my core audience is high school to 34.
Awesome.
People who are either haven't started their careers and maybe haven't even gone to college yet, or they're in college and they're trying to figure out what they want to do, or they're earlier in their career and maybe they want to make a change. So any advice along those lines? You've given a lot of advice already, but if there's something else you're working on right now that you would like to mention, and that kind of advice.
Yeah, I think the only other thing I would mention is there are communities out there, so you don't have to do this alone. I think a lot of times it's harder to start something when you're all by yourself. But increasingly with academia, with what they call open source and open systems and open data, there's a lot of communities that are taking on these hard challenges, like data analysis, like programming, like electronics. You know, if you're so you have three different areas. You can be more of an engineer on the electronic side. You can think about learning how to write code, or you can think about this data analysis, which is at the opposite spectrum. You don't have to worry about the electronics to do data analysis. And I think find a community around one of those things. Figure out what you're curious about, the way people find happiness and satisfaction in their jobs. And your job will include technology in the future. So figure out now, what are the things that you like, or what are the things that you don't like? And then for the things you do like, or that you're curious about, find a community that's working on problems. There's for the electronics, there's makers groups. It's called makers groups, where you build projects with other people. It's all really low cost, really free in most cases. There's people who have, hackathons where you get with a team and they help you learn how to program and solve a problem together. And then there's, hackathons that deal with data. How do we understand, sort of the surveillance videos that are, coming off the border? How can we understand what's happening in those pictures so that we can inform how to help people the best we can? There's all kinds of problems. So you can find where in society you're most interested in having an impact. Figure out what you're most curious about in terms of, where technology might play a role, and then join a community so that you're not alone in your learning process. And all of those things will help you keep you motivated and help make you less discouraged, because it's hard. It's just not easy. If it was super easy, everyone would do this. We'd have all these problems solved 20 years ago, but it's not. Know that it's challenging, and use that challenge as a motivator. It's really exciting when you solve a problem. And so, appreciate those moments, and appreciate the fact that even deciding what you're curious about, which is a hard thing, is an accomplishment, and use that to kind of continuously build on where you're going to have your impact.
Great. Thanks. Great answer. How can my viewers stay in touch with your work, follow your research, see what has been completed and what's coming up and all of that?
Sure. So I have a web presence at UCSB. And really, if you just type my name, Chandra Krintz, or even Chandra, that works still pretty well, because it's a unique name. You will find me, and that's probably the best way. I don't use social networking anymore as much. I did in the past, but I found over the last few years it's hasn't really served us well. And so I'm not very active on that, but I do always maintain my web presence. I make everything I do public. And so my projects are out there, my talks are out there. If there's an opportunity and I'm in your area that where I'm giving a talk, I'd love to meet any of you. So keep an eye out, look for opportunities to listen to people like me to tell you about what we're working on, so that you can kind of figure out where it is that you're going to find your niche. Those are the best ways.
Well, thank you so much. It's been such a privilege and pleasure to speak with you today. We really appreciate it. And we'll talk to you. We'll keep following you and watching all of the very interesting things you're working on. So thank you so much.
Well, thank you. I really appreciate your time and your interest, and I'm really grateful for the opportunity to speak, and thank you for listening.